Assalamu alaikum everyone. Welcome to my presentation. My presentation topic is hybrid convolutional neural network with transfer learning approach for Agro-Crop leaf disease identification. This is Mr. Samil Islam, Computer Science and Engineering, Bangladesh University of Business and Technology, Dhaka, Bangladesh. My paper ID is 2027. In this part, we can discuss our research overflow. That means content. Here we can see different types of content. That is introduction, research motivation and goal, model, methodology, data analysis, experiment result, and conclusion. In this part, we can discuss about introduction. Food safety is a global priority. If food development is not automated and advanced, agro-production quality and quantity can suffer. It's more dangerous if disease control is not developed. Manual calculation are still used in crop disease identification. With the fast reformation of machine learning and artificial intelligence, crop leaf disease identification processing developed on deep learning in substantive agricultural sense has surpassed that of successive agricultural specialists due to the limited data set and the network structure. The complex network structure has an overfitting issue, resulting in lower image recognition accuracy, which cannot match the need for efficient analysis of authentic agricultural work scenes. In this part, we can discuss about our research motivation and goal. Our study process a transfer network to solve the problem. This proposal uses VGG16 and RSNet15 for image analysis. Fine-tuning also improves image analysis. Both algorithms reduce overfitting. Our main innovation is we have improved often the current CNN model by decreasing one of its parameters. Our model's efficiency and processing time were both improved by removing a single parameter. Improvements in performance and assessments of model accuracy thanks to the use of concatenation techniques. CNN claims that their new identifying system is superior to their old classification schema. In this part, we can discuss about our model. From the idea of transfer learning, we have proposed the flowchart model. In this model, crop bridges data passing through the pre-trained convolutional network with fine-tuning for the output generation. In this figure, show that obtained VGG16 and RSNet15 based identification system, which is using training and fine-tuning. Here we can see that data set, and after that we processing the data and we split the data, training data set and test data set. That's mean data classification. And here we can see that VGG16 and RSNet15, that is our two types of model. And after fine tuning, we can improve a model that is known as DL VGG16. And here we can see that RSNet15. After model training and weight integration processes, here we can see that deep convolutional neural network, that means DCNN. And after final model testing, we can finally identification uh, out identification output. In this part, we can see that the methodology of our research. As a retained model of transfer learning for the sake of this investigation, the VGG16 architecture network has been used. In this architecture, VGG16 has been selecting a pre-trained model transfer learning. In the VGG16 model architecture, we have eliminated the fully connected layer on and drop and directly linked with the fully connected layer 2. Secondly, uh, the number of neurons in the remaining two fully connected layer is reduced, while decrement of number of parameters can perform the feature adopted by the last convolutional layer more particular, which is beneficial to enhance the unification outcome. Reducing the depth of neural network is several processes to minimize the number of parameters. That means DLVGG16 is a beneficial to counter overfitting to a particular limitation. And here we can see that our VGG16 improve architecture. Here you can see that input, that is 224 into 224 into 3. And here we can see that our convolutional neural layer. And here we can see that pooling layer. And here we can see that FC layers, that means fully connected layer. And here we use activation function, that name is softmax. And finally, we can see that our output. Here in this part, we discuss about our methodology. Here we can see that workflow of RSNet 15 architecture. RSNet 15 is a pre-trained model of image classification in convolutional neural network, which is applied to solve exploding gradient and degradation problem that face while training a deep neural network model. RSNet 15 has 15 layers and it trained on a million images of 1,000 categories from ImageNet. RSNet 15 contains 48 convolutional layer on average pool layer and on max pool layer, and it consists of 3.8 into 10 to the power 9 floating points operation. The symbol images are fed to the model and various parameters are configured, like the batch size is equal to 32. The number of epoch is equal to 1550 and learning rate is 3 into 10 to the power 2. The workflow of RSNet 15 shown in this figure. In this part, we can discuss about our CNN model concatenation algorithm. RSNet 15 and VGG16 convolutional neural network integration network model have several structures and have their particular convenience and characteristics. The efficient unification of two models can unravel the overfitting issue of the network model of the convolutional neural network. It represents P average, the number of integration models, and I represents the prediction value of the model. This equation represents the mean method of this algorithm evaluation. In this part, we can discuss about data analysis. In this experiment, we have used an image dataset from Bangladesh Agricultural University that's known as Agro-Disease database. For this analysis, the dataset contains a total of 14 class and 13,000 different images. Bangladesh Agricultural University diseases contains a large quantity of image arrangement of crop leaves such as corn, rice, potato. A total of 10,000 images have used for training and verification, and another 3,000 were used for testing. The resolution of the each sample images is 224 into 224 into 3. So here we can see that some samples of Bangladesh Agricultural University Agro Disease dataset. In this part, we discuss about our experiment analysis. The data P10, the data presented in figure illustrates that the DLVGG16 obtain a higher level of training accuracy during the training processes as a faster piece, which is proof that the suggested network has a quick fitting time. In this figure, taking a look, the outcomes of training makes this very clear. When compared the VGG16 network, the accuracy achieved by the DLVGG16 network is a significantly higher. In this figure, if we use the test as an illustration, the improved VGG16 network has a recognition accuracy over 90%, which suggests that it is fitting effect is also significantly improved. The goal of the proposed method is to further improve the recognition accuracy by combining the feature extraction advantage supplied by the DLVGG16 network with the classification characteristics offered by the network. This will allow for a more robust combination of both sets of benefits, enhance CNN's ability to identification disease that affect agro-crops leaves. Here in this part, we can discuss about experiment results. Here we can see that experimental analysis and baseline comparison. In this study, different approaches have been used for image analysis for the identification process. Table 1 have been shown different implements in other research. After analysis and the accuracy comparison, we can see our proposed and pretend model architecture is must outperform. Here we can see that different types of model name, and here we can see that model accuracy. Here we can see that model loss and parameter. In this part, we can discuss about different types of model. That is IPGG16 2021. That's model accuracy 1900 0.5 on, and model loss 9.49. And here we can see that the parameter 1.3 million. Here we can see that VGG16 transfer 2018. Here model accuracy 83.53% and model loss 16.47 and parameter 1.1 million. Here we can see that VGG19 transfer 2018 and model accuracy 84.71% and model loss 15.29. In this part, retained VGG16 2019, here we can see that model accuracy 86.50% and model loss 13.5. And VGG19 2022, here model accuracy 19% and model loss 10%. RSNet 15 in 2019, here model accuracy 95.91%. RSNet 50 2021, model accuracy 98%. And finally, we can show that our improved model. Here we can see that our RSNet 15 model, that's accuracy 99.50% and model loss 0.50, and here we use 1.8 million parameter. Second one, DL 16, model accuracy 96.02% and model loss 3.9, and we use parameter 1.7 million. And here we can see that concatenation mean our proposed model with accuracy 95.89% and model loss 4.11, and here we use 1.3 million parameter. Conclusion: this dataset shows accurate image identification. This algorithm and architecture framework is simpler than others that outperform. We will develop our architecture and improve VGG 16 and RSN 15 based on the experimental dataset and baseline comparison. The suggested algorithm can identify and classify agro-leaves and performs well in network and model simulations. Future research will continue to explore image analysis of disease and pest and calculate crop disease effective area and plant disease and inspect sensitive to properly and effectively treat and prevent large-scale economic losses. Agriculture and AI could improve food security. Thank you, everyone.